This video is all about sequence. Now, sequence are a list of numbers that has a pattern. Now, let me say, for example, you have, let's say, example 1, you have 20, 17, and 14, and you're asked to find the next three terms. And in this list of numbers, each of those numbers are terms in that sequence. Now, if you look at these numbers, they have pattern. Now you see from 20 to 17, from 17 to 13. If you look at it, you will notice that they're adding minus 13 to each of the numbers. Adding minus 13 to each of the numbers. Now if you add minus 13 to 20, it will give you 17. Now if you add minus 13 to 17, it gives you 14. So the next number, if we add minus 13 to 14, it will give us what? 11. It will give us 11. Now let's say we add another minus 13 to 11 to give us 8. We add another minus 13 to 8 to give us what? 5. So see, this is a sequence. This is a list of numbers. Now let's try another sequence or list of numbers that has a pattern, which is called sequence, and each of the numbers is a term. So now let's look at another one. Let's say B, you have 1, 4, 9, and 16. Now you are asked to find the next three numbers. Now if you look at these numbers, look at the pattern, you notice that the first one, which is 1. Now if you want to check the difference, you notice that the difference does not follow any pattern in terms of the difference based on what we did here. See, 4 minus 1 is 3, 9 minus 4 is 5. So see, now 16 minus 9, 7. So but the patterns it takes is when you say 1, it's a square. This 2 square. This is 3 square will give you 9. 4 square will give you 16. So you see the pattern it follows. You say 1, 2, 3, 4. So the square, meaning that the next one here should be 5 square, which is what? 25. The next one that follows is 6 square, which is what? 36. The next one is what? 7 square, which is what? 49. So the pattern is 1 square, 2 square, 3 square, 4 square, 5 square. So the pattern is just the first term. The pattern is just a number raised to power 2. So if I want to write now, look at here, you have a first, second, third, fourth. So the n term of this particular expression, this particular one, there's a b expression will be n to the power 2. So this is the n term of this particular expression. If I want to find, I want to express it in terms of formula, that is in terms of a function. Now, if you look at this one here, this is what we call arithmetic progression, because this one has a difference, a common difference, which is -3. But this particular problem does not have a common difference. The only one this, if you look at it in formula form, is n squared. It's a quadratic pattern sequence. So now let's look at another one. Let's just clean this and look at another particular problem. Now let's look at another sequence of numbers, or list of numbers. You have 1, the next one is 2, 4, 8. Now if you look at these numbers, there is an increment. Now you have the first one is 1, the second one is 2. Now 2 raised to power 1, the next one is 2 raised to power 2. That is the pattern I'm seeing. The next one is 2 raised to power 3. So now if I was asked to find the next three terms, now you see the whole thing, you will not see the pattern I'm seeing here now is, n. Now you see the first term, the second term, the nth term will just be 2 to the power n minus 1. That is the function, as in the nth term of this sequence. Now, you know, the 1 is equal to 2 raised to power 0. So we know anything raised to power 0 is equal to 1. So that is it. So now that means you have here 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. This will give you 1, this will give you 2, this one will give you 4, this will give you 8. Now 2 raised to power 4, the next one is 0, 1, 2, 3, 4. So 2 raised to power 4 will give you what, 16. 2 raised to power 5 will give us what, 32. 2 raised to power 6, 2 raised to 4. Let me just clean erase this. 2 raised to power 6 will give us what, 64. So then if you look at this, this is the pattern of this particular list of numbers. So that is how you can get the next three terms. Now also note that each of the numbers are, in this list of numbers, each of the numbers are tens. We call them tens. So that was why I say the n term, which is t subscript n. The first term is t1, the second term is t2, the third term is t3, t subscript 3, the fourth term t subscript 4. So the n term is this. So based in terms of function, that is sequence of function, that is 2 raised to power n minus 1. Now this is how we're able to get these values. Now let's look at another one. Let's say this is C. We have a D, part of the question. Let's say you have, now for the D, let me just erase, let me clean this part. Let me erase this, okay? Now, let's say we have a number, we have minus 12, minus 6, minus 3, and minus 1, 1/2. Now, let's use arithmetic progression method to see if we can see any pattern here. Let's say the second term minus the first term. So we just say minus 6 minus 12. This will give us 6. Now the third term minus the second term will give us what? Minus 3 minus 6. So we're looking at the common difference. Whether is there any common difference? Is there any pattern which is the arithmetic progression? So now what we have is minus is plus 3. Now see there is no pattern here. So the fourth term minus the third term, this will now give us what? Minus 1/2 minus 3. So this will give you, this is minus 3/2. This one is plus 3. So this one will now give us 6 minus 3. So 6 minus 3. So over 2, that will give us 1 all over 2. So you see, there is no common difference. Now let's look at geometric progression. Now in geometric progression method, we just say T2 divided by T1. This will give us what? Minus 6 divided by minus 12. This is equal to half. Then T3 divided by T2. T3 is minus 3 divided by minus 6. This will give us also half. So T4 divided by T3. This will give us what? This is 3 all over 2 minus 3/2 divided by minus 3. So this will also give us half. So now this has a common ratio. Call this common ratio. That's a common ratio which is R. So there is no common difference here. So now for us to now look for the third term, that means, let me now clean here. Well, if I want to look for the three more terms here, let me just delete this. So we have gotten the common. What we got here is just the common difference, not a common term. So sorry, the common ratio, not the common difference. So now From this expression, that means that for you to move, for you to get from the first term to this, you're multiplying minus 12 by half. For you to get for you to get from here to here, you're multiplying again minus 6 with half. For you to get this next one, you're multiplying minus 3 with multiplying with half. So now this expression is minus 3 over 2. For us to get the next term, that means we multiply this term with what? Half. Then the next one, the same thing. We multiply with what? Half. So now let's multiply this minus 3 over 2 by half. We now have what? 3 over 4. Now let's multiply this 3 over 4 by half. You have minus, so because there's minus here, so the next one, if you multiply minus 3 over 4 by half, you have minus 3 over 8. So the next one, if you multiply minus 3 over 8 by half, we're going to have minus 3 all over 16. So this is the 3 terms that we're looking for. So that is how to solve this particular sequence. This is how to solve the sequence problem. So this sequence is called geometric progression. It's a geometric progression because each of the terms are gotten by multiplying a common ratio. But arithmetic progression is you add a common difference to get it. While the common difference might be a positive number or a negative number. Now, this geometric progression might be a fraction this geometric ratio might be a fraction. For geometric progression, the common ratio might be a fraction or an integer. Now, but for this case, it's a fraction that we're using to multiply. So that is it. So let me delete this. Now the next one, let's say you have another problem. You have 1, 3, 6, 10. So this list of numbers. Now let's look at the pattern. Let's look at the pattern how these numbers were generated, so that we can be able to get the next 3 terms of these particular numbers. Now, if we use the difference, say the second term minus the third term, like we are looking at arithmetic progression, whether there is there any an arithmetic progression pattern that is here. So now we try by looking for a common difference. So now say 3 minus 1 will give us what? This is 2. So the third term minus the second term will now be 6 minus 3. This will give us what? 3. The next one, the fourth term minus the third term will give us what? 10 minus 6. This is 4. So actually there is a pattern here. You have 2, 3, 4. But let's look at the geometric progression. Let's look at what it gives us. So now For geometric progression, we just say the second term divided by the first term will give us what? That is 3 over 1 is 3. The next one is the third term divided by the second term will give us what? 6 divided by 3. That is 3. Sorry, that is 2. That is 2. Then the next one, let me erase this. This is equal to 2. So the fourth term divided by the third term will give us what? The fourth term is 10 divided by 6. This is equal to 1 point 1 point you have 4. That is 6. 667. So you see, there is no common ratio, no common ratio, and there is no common difference. But there is a pattern here. You see the pattern. You have 2, 3, 4. So that means the next one should be 5. So that is how we're going to get. Let me now erase here. Let me erase this. So that means the process is from here you add plus 2, you have 3. From this other one you add plus 3, you have 6. So 3 plus 3 is 6. 1 plus 2 is 3. Then the next one should be plus 4. So 6 plus 4 will be 10. Then that means the next one here now will be plus what? 5. So 10 plus 5 will give us what? Give us 15. So the next one should be what? Plus 6. So 15 plus 6 is what? 21. So this is a pattern. Having studied the list of numbers, you will now notice that it has a pattern, which is, and the pattern starts from plus 2, start adding plus 2 plus 3 plus 12 plus 5 plus 6. So from the first term to the third term, you add plus 2. From the second term to get to the third term, you add plus 3, like that. So incrementally. Now let's now get the last 3 term. Sorry, the last additional 3 terms. Now you now add plus what? 7. So if you add plus 7 to this, it will give what? Plus 7 to 21 will give us 28. Give us 28. 28. So that is it. So this is how the next 3 terms can be gotten. Now let's look at another problem. Let's look at another one. Let's say you have 1, so you have 20, 17. Okay, done this from done this. Let's look at another problem. You have 8 0.8, 0.008, 0.00, 0. Sorry, let me erase this. You have 0.08, 0.008. So if you look at this, you notice that it is a geometric progression. Now, it will not be an arithmetic progression. So now if you look at, let's say, the second term divided by the first term, you have 0.8 divided by 8. This will give you 0.1. Now the third term divided by the second term, this will be 0.08 divided by 0.8. This will still give us 0.1. So the fourth term divided by the third term, 0.008 divided by 0.0. This will give us 0.1. So the common ratio is what? 0.1, which is the same thing as 1/10. So that is what we're going to use now. This is what we're going to use to get the next three terms of this particular problem. Now, from here, if you multiply 1/10 to give us this, then the next one, if you multiply 1/10, gives us this. So if you multiply 1/10 to this term, it will give us this. So just the same way now, for us to get this other term, we'll now multiply 1/10. So having gotten the pattern, we can now be able to get the next three terms. So 0.008 times 1/10 will give us 0.0008. Now the next one also you multiply by 1/10. So if you multiply by 1/10, you have 0.00008. This is 3 zeros, this is 4 zeros. So the next one should be 5 zeros. So now if you multiply 1/10, you multiply this by 1/10, you have 0. You have what? You have 0. Now have 0.00008. This is 5. This is 4. 3, 2, 1. Okay, 0. So now that is it. That will be what will be here. So that is a sequence. That is all about a sequence. So that is all about a sequence. So now let's clean this and try another one. Now you have problem like this. This other one, you have 3 minus 6 minus 12 minus 24. So if you look at this, numbers, without being told it is a geometric progression. So for us to now go further, let's use geometric progression instead of going into arithmetic and then delaying our time. So now divide the second term by the first term. You have minus 6 divided by 3. This will give us minus 2. Divide the third term by the second term. You have minus 12 divided by minus 6. This will give us 2. Then divide the fourth term by the third term. This is minus. This is minus 24 divided by minus 12. Minus 24 divided by minus 12. Okay, sorry, here is supposed to be plus. So here is plus. So here should be minus. So here is plus. So it should be minus 12, minus 2. So you see, it has a common ratio which is equal to minus 2. So on this ground, we have been able to unravel the pattern of these numbers. We've been able to unravel the pattern of this list of numbers, and the pattern here is multiplying let's say this first term with minus 2, multiplying it with minus 2. Then the next one also, you multiply minus 6 with minus 2. You multiply this plus 12 by minus 2. Now for us to get the next term here, we also multiply by minus 2. So we multiply minus 24 by minus 2, we are going to have 48. Then the next one, the same pattern, you have multiplied by what? Minus 2. So minus 2 times 48 will give you minus 96. Now, if you multiply minus 96 by minus 2, so we now have plus. This one plus. Let me just change the color. This is 2. 192. 192. So that is what we're going to get. So you're going to have 192. And it will be a plus because this one is plus minus plus minus plus minus plus. So that is it. So now we also have another kind of sequence, another kind of sequences. That is a list of numbers. We have another list of numbers like this. You have 1 all over 2, 1 all over 3, 1 all over 4. So to find the next three terms, if you check the pattern, the ones, the denominators are 1, 1, 1. The numerators increase by 1, 1, 1. So you have 2, 3, 4. So this time is the next one will be 1 all over 5. The next one is 1 all over 6. The next one is 1 all over 7. So that is it. So now let's look at another one. Let's look at another problem. you have 0, 1, 1, 2, 3, 5, and 8. Now, if you look at this list of numbers, now for us to look at how the pattern, how some of these terms are gotten, what we're going to do is now, if we just say, if you just say 0 plus 1 to give us what? 1. Now, if you say, then now you have 1 here. Now, for this other one, so that is how to get this. Now, for this other one, now for this other one, for here, we have explained how we got this. That is 0 plus 1 is 1. Now, to get this is 1 plus 1, 2. To get this is 1 plus 3. Yes, this one is 1 plus 1. This 1 plus 1 gives us this. Then this other one is 1 plus 2 gives us what? 3. Then the next one is 2 plus 3 gives us this. The next one is 3, this 3 plus 5 plus this 5 gives us this. So that is it. So now to get the next 3 terms, you see the next 3 terms, you will just say now 5 plus 8 will give us what? 13. So the next one is 8 plus 13 will give us what? 21. Now 13 plus 21 will give us what? This is 34. So that is it. So thank you for watching till the end. Have a nice day.